Okay, so here is the video notes for solving quadratic equations using square roots. To understand how we can use square roots to solve quadratic equations, we need to understand how how square roots and quadratics are related. So up here I have some examples of some numbers that are squared, like a quadratic would be. 4 times 4, we know 4 times 4 as 4 squared, right? 4 times 4 is 4 squared, which in turn equals 16. Now, if I were to take the square root of 16, I would get 4. So what I want you to see here is that 4 squared is 16. By squaring the 16, I get the original number back that I started with. So same thing here with 11. 11 times 11 is 11 squared, which is 121. Now if I wanted to get that 11 back, I could just square root the 121 and get the 11 back. So you need to understand that squaring something and square rooting something are the exact opposites of each other. Much like if we had the equation, let's say we had x plus 3 equals 5, and asked to solve, you would subtract 3. Why would you subtract 3? Because you have addition. And the opposite of addition is subtraction, and that's how you get rid of it. So this works the same way here. When you have a squared, if I want 11 squared is 121, if I want to get the original number back, you would do the opposite, which is square root. So squaring and square rooting are opposites of each other, and you can use them to solve quadratic equations. So same thing here, square root of 9. Square root of 9 is 3. But if I want that 9 back, I could simply just square it and get the 9 back. See how they're opposites of each other? Before I was square rooting, now I'm squaring. Square root of 121 is 11. But if I want that 121 back, I could just square it and get my 121 back. That's supposed to be 121. So how does that help us in solving? So again, what that means that if b times b is some number, then if I square root some number, I would then get the b back. So how does it help us solve? Okay, one thing that we need to understand with square roots as well is the fact that, let's say, so we understand that the square root of 81, you've always written the answer as 9 and moved on. The problem is that that's not completely true with the answer to square root of 81. The square root of 81, whenever you square root something, you are always going to get two answers, a plus value and a minus value. So the answer is actually plus 9 and negative 9. So we write that as plus or minus 9. The reason is because if I want to get the 81, if I want to get the 81 back, and I chose to square 9, if I square 9 or whether I square negative 9, both of them, 9 squared is 81. Well, negative 9 squared is also 81. So both of these answers give you 81, so I have to take into account both answers. Prior to now, you've always just done, oh, square root of 81, it's 9. Well, it's not technically true. It is 9, and it's also negative 9. So anytime you take the square root of something, you need to remember that it is always the positive and negative value of that answer. So if you look at b, square root of 49 is going to be plus or minus 7. Now, the difference is when you have a negative out here, it then just makes this negative 7. So this answer would be just negative 7 because of the negative that's out here. Okay. C, square root of 0.16 is let me do that, 0.4 plus or minus. Okay, and you can do these in your calculator. And then we should all be able to recognize this by now. Okay, can we do this problem? The answer is no. You have a negative inside the radical. You cannot take the square root of any negative number. So for this one, no solutions. Okay. All right, now how does that help us with quadratics? Well, quadratics are things that are squared. Now, obviously, you wouldn't do this all the time. You really can only do this if there is only one x in your problem. Let's zoom out so you can see all of these problems here. And I'll scroll down too. But notice in all of these problems, there is only one x. There's one x. 1x. You know, 1x. 1x. You know, 1x, 1x. Okay, 1x, 1x. Even though they're x squared, there's only one variable. There's only one x. In previous quadratics, you always had, you know, something that looked like this, where you had an x squared and you had an x. Okay, and so we've solved them different ways. You can't do this when you have multiple x's or multiple variables. This only works when there is only one variable. So you can do this. It's kind of a shortcut here, but you can do this only when there is one of the variable. Okay, so just hammer that into your brain. You cannot do this any other time other than when there is only one variable. So remembering that by squaring x, you get 25. But if I want that x all by itself again, what did we do before? Okay, since this is squaring, I could simply just square root the 25 to get the x by itself. Now, what you do to one side, you always have to do to the other, so we square root both sides. But the square root and a square actually cancel out, leaving you at just x equals square root of 25, remember, plus or minus 5. Okay. Now, let's look at number 2. Now, in order to do this, you need to solve for x, just like you would in any other problem. So we do need to get the x by itself. So this shouldn't be too difficult. But I'm going to add the 64 over to the other side because I'm trying to get the x by itself. Cancels. X squared equals 64. And now I have the x by itself. To get rid of that square, I can square root both sides. That cancels, leaving me with x equals, careful, plus or minus 8. Now the problems do get a little more complicated as you move on, as we see here. Again, the goal with these, first of all, look to see if you have just one variable. If you have one variable, then you can do this. You can solve for x. So I have one variable, so I'm going to solve for x. The x squared, the x is not by itself, so I'm going to divide by 6. Divide by 6. I get x squared equals 9. Then, to get rid of the square, I can square root. X equals plus or minus 3. Same thing over here, number 4. Solve for x. So x squared equals 25. To get rid of the square, just square root. And x equals plus or minus 5. Very important to remember that. Plus or minus. Okay. I'm going to let you try. Let's let you try 5, 6, and 7. And yeah, we'll do 5, 6, and 7. And then pause the video. And then hit play when you're ready to check your answers. Okay. There's the answer to number 5. Subtracted or added the 300 over to the other side, then divided both sides by 2, giving me 150. X squared equals 150. Square rooted both sides. Yes, you will get decimals in a lot of these problems. So square rooting 150, you get plus or minus 12.25. Alright, Here's the answer to number 6. X equals plus or minus 5. Okay, and number 7. All right, there is X equals plus or minus 3.46. Now, fractions always present issues in that of themselves, but the problem isn't any different than what we just did. You're still trying to get X by itself. So when we subtract the 3 over, you're going to get 3 over 7x squared equaling 21. Now there's a couple ways you can do this. You could divide both sides by 3/7, or if you're not good with fractions, you can do what I would do and just get rid of the fraction. We can get rid of any fraction by simply just multiplying everything by the denominator. By multiplying by the denominator, it will get rid of that denominator, leaving you just 3x squared equaling 21 times 7, which is, let's see, 147. So now we're going to divide by 3, and that gets us x squared equals 49, and then square root both sides, giving us x equals plus or minus 7. So fractions always present issues, so be careful with that. I just like to play it safe and just get rid of the fraction. You could even do it in the very beginning here if you wanted to get rid of the fraction just by multiplying everything by 7. And that would get rid of the denominator. So it's up to you on how you want to do that. Okay. Why don't you go ahead and try 9 and 10 on your own, and then so pause the video, do 9 and 10, and check back, hit play when you're ready to check your answers. Alright, there's the answer to number 9. Adding the 3 over, getting you 80. Getting rid of the fraction by multiplying both sides by 5. That leaves me with 4x squared equaling 400. Then dividing by the 4, getting me 100. And then finally, since the x is by itself, square rooting both sides and getting plus or minus 10. And on number 10, you can see here, as I subtracted the 8 over, I got 375. To get rid of the fraction, I multiplied both sides by the 3, getting me 1,125. Divided both sides by the 5, got 225. Then square rooted both sides, giving me x equals plus or minus 15. Now I wanted to show you real quick one other type of problem that I didn't get to put on here, but is something you're going to need to know how to do. So I'm going to find some space here. On my paper it looks like I have some space kind of in the corner here. So another type of question that you may see, and we'll call this, since we don't have one, we're going to call this number 11. Another type of question that you might see is something like this. Okay, so in this case, here's your problem. Okay, my squared is this entire thing. So instead of getting the x by itself, I need to get this thing by itself, because this is what's being squared, this entire thing. So I am going to still subtract the 5 over. Let's choose a different color here. I'll do black. So we're still going to subtract the 5 over, giving us x plus 3 squared equaling 5. But since this whole thing is being squared, I had to get this thing by itself. Now that this thing being squared is by itself, just like before when we did the x by itself, this whole thing's just squared. So I had to now get this by itself. Then I can square root both sides. Now I didn't really make this very easy on you guys. Tell you what, we're going to make a change here. Let's see if I can do this. Doesn't let me erase. Let's make this 13. This is going to be a 13. so that when you subtract the 5, you get 8. There you go. Yeah, that won't be as messy of a decimal. Nope, take it back. Sorry guys, I keep changing this on you. Let's make this 14. Sorry, that would make this a 9. Yeah, let's make it real easy. Sorry, I apologize, this is kind of last minute. But we're going to make that 14 just so we get a perfect square. So when I square root both sides, what it does is it gets rid of my square root and my square, leaving me with x plus 3 equaling plus or minus 3. Now here's where the tricky part comes in. Because you have an answer of plus 3 and minus 3, when you go to solve for x here and you go to subtract 3, you have to subtract 3 from both 3 and negative 3. So by subtracting 3 from positive 3, 3 minus 3, you're going to get that x equals 0. And if you subtract 3 from negative 3, you would get negative 6. So let me show you again how that works. Remember, you had an answer of plus 3 and minus 3. So when we subtract the 3 to both sides, here's what you got. 3 minus 3 is 0, negative 3 makes negative 6. And that's how you got your two answers. Don't worry about that type of problem. You know, we'll go over that again when we go to review for your unit test after spring break. But that's the other type of question you'll see. Your homework is on, or your homework, your practice is on Canvas. I suggest that you do at least the majority of the problems on there to get some extra practice. You're not going to have a quiz on this or anything for that matter on this until after you come back from spring break. So I want to make sure that you guys know what you're doing before we send you off on spring break. So that's that. And if you have any questions, send me a Canvas message or you can send me a pass to come in during AL. All right.